So this question is about cumulative frequency, and it is showing the frequency of different distances of javelin throws. So Kerry's thrown it 30 times, and this shows us how many times she's got within the varying distances. And what these mean are that for the distance between greater than 30 metres and less than or equal to 35, Kerry got 1 throw in that group. And in the second group, which is greater than 35 and less than or equal to 40, she got 7. So what we're going to do to get our cumulative frequency is it's like a running total. So at the end, all our throws should add up to 30, because all 30 of them will be less than or equal to 55 metres. So the way we start it, we have 1 in the first row, because only 1 throw is less than or equal to 35 metres. And then we are looking for how many throws are less than or equal to 40, and that is 1 plus 7, which is 8. And the next one, how many have we got that's less than or equal to 45? And it's all of these 3 added together, 1 plus 7 plus 13, which is our 8 plus 13, or 21. And we carry on, just adding them up as we go. 21 plus 5 is 26. 26 plus 4 gives us 30. And that's what we were hoping to get to. So now we're going to plot them on a cumulative frequency diagram. And we are going to use the upper end of the grouping and plot it against the cumulative frequency. So the first one is 35 at the top end, and we're going to plot it against 1. So we'll find 35 here, and I will try to do it against 1. It's a bit tricky. And the next one we're going to do at 40, because that's the top end of the grouping. So 40 and 8. So 40 and 8 on the vertical scale, it looks like it's 1 square per 1 number. The next one we'll do is 45, and we'll do it with 21. So 45 here on the x-axis, and we'll go up to 21. And then we're going to do 50 and 26. So 50 here, all the way up to 26. And finally 30 and 55. There we go. And now we can plot a curve, cumulative frequency curve, whoops, went a bit wonky, through here. So obviously if you've got a pencil and rubber, you can redo it if you're not happy with it. The next part of the question is the qualifying distance for a competition is 48 metres. And we've got to estimate the number of these throws that reach the qualifying distance. So what we want to do is draw a line up from 48. So first off, we need to figure out what 48 is on the bottom axis. And because there's 10 squares representing 5 metres, 2 squares will represent 1 metre. So 48 would appear here. And what we want to do is draw a line straight up there. Obviously, if you've got a ruler, it will be better. Something like that. And then we're going to draw a line along and see where that meets the y-axis. And I think, without drawing the whole line, it will meet around here, which is 24. So that shows that 24 throws are 48 metres or less. And if they need to be 48 to beat, to qualify, then we've got to do 30, take away 24, because there's 24 that don't reach it, and that will give us 6 that do qualify. Obviously, depends it quite on your graph, and when an examiner marks it, they will read it accurately from your graph. So the next part of the question, you'll see we've got a histogram, and a histogram looks similar to a bar chart, but the main difference is that you have this thing called frequency density on the side rather than the frequency, which is the number of throws or the number of whatever it is we're looking at. And you might notice that the bar widths are different. So here we've got a width of 10 metres, but these are narrower, they're just 5 metres. So when you're plotting a histogram, to work out the frequency density, what you do is you work out your frequency and you divide it by the group width, and that will give you the frequency density. But when we've got a histogram and we're trying to work out the frequency, what we do is work out the area of the block or the bar that we're interested in by multiplying the width of it by the frequency density, and that will take us back to the frequency. So, for example, if we wanted to know how many throws Lola got between 25 and 35 metres, the area of that little rectangle would be 10 wide, and the height of it would be 0.3 by the look of it. So it would be 10 times 0.3 or 3. It would be, and she got 3 throws within that size between 25 and 35. But the question in this case, it's asking which girl is going to get the greater estimated proportion of throws reaching the qualifying distance. So proportion is a key word here. We know that in the first part of the question, there were 6 out of 30, I think, that we think would have qualified. But in this case, Lola's done 50 throws, and we want to work out, again, if we're looking at over 48 metres, what proportion of throws Lola is getting over 48 metres. So we need to work out from these the number of throws over 48 metres. So again, if I draw a little line down here, you have to imagine it's straight. We're working out the area of this thin part here and also this bar here. So this one here is slightly easier. Sorry, I don't know if you can see which one I'm pointing at. This one, because we know we've got both dimensions there. So for Lola, greater than 48, we've got, or greater than 50, I should say, we've got 10, which is the width here, and the height, which is 0.2. So 10 times 0.2 gives us 2 throws. So she got 2 throws in between 50 and 60. And then, because we're trying to work out the part of this bar that's greater than 48, we know actually that what our width is going to be 2 wide, because 48 up to 50 is going to be 2. The height of it is 3. So we can work out that bit by saying it's 2 times by 3, and that should be 6. So this is the number of throws that Lola got, which are qualifying greater than 48 metres. So 8 altogether. So for Lola, she got 8 out of 50. Whereas Kerry, we worked out from before, got 6 out of 30. So we need to work out which is the greater proportion. Different ways we could do it. I would be tempted just to do it on my calculator. Lola's, I can see straight away, is, let me change colour, is 16%, because if I double that, it will give me out of 100. So Lola's is 16%. Kerry's, I'm actually going to do on my calculator, or do I need to? If we simplified that down, we could have 1 out of 5, which would be 20%. Actually, we don't need a calculator. So the one with the greater estimated proportion was actually Kerry from the previous slide. So that would be your answer here.